Assalamu alaikum. Lab 3, Loops in Assembly Language. In this lab, we are going to discuss how we can use loops in our assembly language programs. The aim of this lab is to use loop for data manipulation. The first exercise is to define 3 arrays to hold 4 1-byte integers. Initialize the first two with the numbers 2, 3, 4, 5 and 3, 4, 5, 6. The solution of exercise 1 is to declare 3 arrays, array 1 of byte data type, and it will be initialized with the values 2, 3, 4 and 5. And array 2 of byte data type will be initialized with the values 3, 4, 5 and 6. And third array is left uninitialized, but it can hold 4 values. Let's explain this code. It is written in .data. It is written in .data as variables can only be declared there. 2 arrays are being created to which 4 values are assigned. The array are of byte size, that is each value takes a space of 8 bits. Array 3 is initialized by putting question mark in the 4 slots as there are no value that exist there at the moment. This was the solution of exercise 1. Now let's discuss exercise 2. The question of exercise 2 is to write code, assemble and execute it. To display the sum of each of the first 2 arrays in registers EAX and EBX, print the following message before the results are displayed. The sum of the arrays are shown in the register EX and EBX. The solution of this exercise starts here. First of all, we will include library erwin32.inc, and here is the data block which we have already initialized in the first exercise, but with addition to that data we are including line variable which is of byte data type and it holds the value of these characters. The sum of the arrays are shown in the registers EX and EBX, comma 0. It means this string is null terminated. After that we will start code here. This is the main procedure. It starts here and ends here. First of all, we will move length of array 1 to ECX. It will provide the length of array 1, which is 4 in this case, and it will move offset array 1 and offset array 2 to ESI and EDI registers. These two statements will provide the address of array 1 and array 2 to ESI and EDI to start with. In the next two statements, we have initialized EAX and EBX with 0 to avoid any garbage values. Here we can start our loop. It will start with the sum title name and it will end here. In the first statement, we will add into AL and then we will add EDI into BL and increments ESI and EDI. The addresses of ESI and EDI will be incremented till the end of this loop, which is the length of 4. After that, We will move offset line. This is the name of variable, and its address will be moved to edx, and we will call write string function. Write string function is a built-in function. We can use it to write null terminated string on the consoles, and then we will call dump register to show the values of the registers. This is the line we have printed here. The sum of the arrays are shown in the registers EAX and EBX. Let's discuss its explanation. The two arrays along with the line are declared and initialized in .data. These were the two arrays we have initialized and declared in .data. In .code, array length is sent to ECX, which is the register that stores the value of how long the loop should run for. So in this case it is 4, as array length is 4, and this is the statement which is telling ECX the length of loop. The length of array 1 will provide the length of array 1, which is 4 in this case. In the ESI and EDI, address of array 1 and array 2 are being moved by using offset keyword respectively. After this, EX and EBX are set to 0. EX and EBX are set to 0. Then the loop is run, which is named sum. As the loop runs, the sum of array 1 is stored in AL, and sum of array is stored in BL. Dump register is called, and value can be seen in EX and EBX. Sum of array 1 is shown as E in hexa, which is 14 in decimal, and sum of array 2 is shown as 12 in hexa, which is 18 in decimal. Let's run this code in Visual Studio. Here we have the data block where we have initialized these two arrays, and this is the code block where we have created length of array 1 and moved it to ECX, and then we are using loop sum here, and it will add contents of ES into AL and BL. It will provide the sum of array 1 and array 2. And then we are printing line variable which holds the value. The sum of the array are shown in the registers EX and EBX, and then we are calling dump registers. And this is the result of this program. Exercise 3. In exercise 3, we have to write code, assemble and execute it to store the sum of the corresponding elements of the first two arrays in the corresponding elements of the third arrays. That was defined in exercise 1. Display the sum stored in the array on the screen reading directly from the memory. Print the following message before the results are displayed. The sum of the elements of the arrays are shown below. This is the solution of this exercise. In the data block, we have initialized 3 arrays by array 1, 2 and 3, and In array 3, we will store the sum of array 1 and array 2 of individual elements, like we will store on index 0 the sum of 2 and 3, which is 5, sum of 3 and 4, that is 7, sum of 4 and 5 in index 3, which is 9, and sum of 5 and 6 on last index. To solve this exercise, we will write code in main procedure. We will move length of array 1, that is 4 in this case, and this will be also the counter for loop, which is sum. Then we will move offset addresses of array 1 and 2 and 3 to ESI, ED and EBP registers. In the loop, we will move ESI, EDI into AL and add them. And after that, we will move EAX into EBP and increment ESI, EDI, EBP. And then we will print line by using write string, and we will call dump memory function to directly read from the memory. The variables are initialized in dot data just like in exercise 2. Then length of array moved to ECX for loop counter. Addresses are moved to ESI, EDI and EBP of array 1, array 2 and array 3 respectively. The loop is run and the element-wise addition of the two arrays takes place, and the result is stored in array 3. In EDX, offset of line is moved and it is printed using write string. Then call dump memory shows us the result stored in array 3. First value is 5 in hexadecimal, which is also 5 in decimal. Second is 9. Second is 7, both in hexa and decimal. Third is 9, both in hexa and decimal. And lastly, B in hex, which translate to 11 in decimal. The values matches the expected results as we have discussed before. In this lab, we learned how to use the loop in assembly language, gaining a more detailed understanding of it. Now, not only this, we also learned how the arrays worked as well as how to assign values to it. How to find its length? We came to know that register ECX is used for loop counter. Apart from this, we also came to know how to print out a string. Lastly, we learned how to output the result of a specific variable in assembly language as well.